I love dogs. So I want to talk about dogs today. And the best thing is I'm going to use this API called dog.ceo, which is a real API. I kid you not, it is fantastic. I'm going to use, all my pictures are from there today. But before I get started, I want to say a big thank you to the conference organizers, Daniel and Matt, Bjorn for wrangling us, and everybody else that I'm probably forgetting. I say that now because I tend to get going and I pick up steam. By the end of the day, I won't even remember what I said. I'll just be like, dogs and APIs and JavaScript and things like that. But I want to give a extra special thanks to my fiance, Lauren, who she puts up with me all the time, and she's definitely the best thing that ever has and will happen to me. And we got engaged the other day. It was fantastic. It was actually in Interlaken, a beautiful city. And thank you. But now let's get a little serious. Let's talk about coding. Let's talk about performance. Because it's the year of the dog. 2018, the year of the dog. And that actually works with this talk. And I have a question to ask you. Do you care about performance? Yeah, of course you do. You're at a conference, you're here to become a better engineer, become to write more efficient code, and you're going to learn from a lot of smart people today. So, okay, we all agree we care about performance. But before I get into performance, I want to tell you a story. It's a story that I like to tell a lot because it's a story about the hardest interview question that I've ever been asked. I know, how does this relate to performance? Don't worry, we'll get there. The hardest interview question I've ever been asked, it was actually a few years ago. It was at Netflix. I was just a humble engineer in New York, and I came in, and they said, like, hey, you want to interview for Netflix? I said, yeah, sure. Why not? You know, worst case, I get some free Netflix. That's cool. But I remember this question because it stuck with me for years. It actually made me the engineer I am today. It's the way I think about problems. And it was the end of the day, and I was so tired. And they said, Jem, you've done pretty well so far. Last question. How do you have perfect engineering and perfect design? I thought, oh, well, you just, well, the design, you just make it really simple and no. And I thought about it, because it's really about the balance between the two. And actually, I really don't remember the question that much, and I don't remember the answer that I gave them, but apparently it was good enough because they hired me. But really, the question just stuck with me, and especially regarding to, when I think about performance, I think about, okay, we have performance on one side. What are we trading off on the other side? Because there's always a trade-off. Engineering is all about trade-offs. And for a long time as engineers, we've gotten away with it. We've gotten away with not thinking about performance because the internet, it gets faster and faster every year. Computers get faster and faster every year. Over the past 6 years, did you know that the average internet speed has tripled? Tripled. So I had to ask you this question. Are websites three times as fast? Why not? So I ask you again, do you care about performance? I don't know if we do, because we think we care about performance, but we've gotten lucky. We've gotten lucky that computers are faster and the internet's faster, but we haven't thought about the trade-offs that we're making. We think about performance in terms of our performance. What makes us better engineers? What framework is going to make us a little bit faster, a little bit shinier? What kind of computer is going to make us a little bit better? What kind of code font do we use in our editors that is just like, man, this is going to be so cool when I screenshot my code and put it on Twitter? But we never think about the trade-offs that we make when we build things. And engineering is all about trade-offs. Today I want to talk about 3 aspects of performance. I want to talk about developer performance, I want to talk about application performance, and I want to talk about server performance. But more importantly, I want to talk about a new way of thinking about how we build things and how we think about performance. My name is Jem Young. I'm a senior software engineer at Netflix. And in every talk, I like to say a random fact about myself so that we're friends. It's not just me lecturing you. We feel a little bit of a bond. And a weird fact about myself is that I solve most of my hard problems in the shower. I do. I go in the shower with a hard problem and I come out with a solution. And sometimes random thoughts just float through my head while I'm trying to think of these solutions. For instance, the other day I was thinking, why is Fast and Furious such a terrible franchise? Like, it literally makes no sense, but I love them anyways. I will go see them in theaters every single time. But the storyline makes zero sense. Or what is it about laser pointers that just drive cats insane? If there's a cat sleeping and you shine a laser pointer, it'll wake up and like just chase the laser pointer. I don't even know how they know. But other than random thoughts about cats and Fast and Furious, sometimes I actually think about work, and I think, what is performance? What makes up performance? Well, on one hand, you have developer performance, you have server performance, you have application performance, but what about the other side? That's one half. What about the trade-offs that we make to achieve this performance, to achieve better developer performance or server performance? So today, this is the structure that I want to talk about. I'm going to talk about building performance in all the three aspects, but I also want to talk about the trade-offs that we're making. And a good way of thinking about trade-offs is thinking about the best site on the internet. What's the best site on the internet? Go ahead, shout it out. Anybody? Reddit? Come on. Netflix? Nice try, nice try. No, the best site on the internet is a little site called Craigslist.org. RIP personal section. It's gone now. A lot of broken hearts out there tonight. But Craigslist is this paragon of simplicity. It's just HTML, CSS, and a tiny bit of JavaScript. The UI is simple, it's fast, it loads under a second, and best of all, it displays all the information to the user on first load instantaneously. That's a brilliant site. So, we talk about performance. I say, like, I want to build a fast app just like Craigslist. I can use just HTML and CSS, right? No, of course not. We don't build like that. Because if we did that, we would definitely limit the features that we can build. We can limit the places that we can be in the future when we talk about building out a future app. So that's why we need to think about performance. We can always get some sort of performance, but what's the trade-off that we're making to get there? And when it comes to developer performance and application performance, the most important one, in my mind, is developer performance. Why don't we write all of our websites in assembly? That would be fast, right? We don't do that because it would be insanely hard to debug, and it would take forever, and we couldn't hire assembly programmers. No, we build things to make ourselves more performant. So the developer performance is actually the core. It builds the foundation for application performance and server performance. And when we think about developer performance, it's really about being productive. How can I make my team more productive? How can I make myself more productive? And the foundation of all of this is the one that's most overlooked. It's the architecture of your code. How often do we think about how we structure our code, how we structure our folders? We usually don't. We just throw it out there and we're like, yeah, that's good, and it builds and it builds and it's built. And you have this giant spaghetti monster, and it takes you hours and hours to debug anything. In fact, a quick show of hands, who here works in a largish code base? We'll say like 10, 20,000 lines, something like that. Most people. Okay, you can put your hands down. Now, how many people out there have ever had to make a simple bug fix? Like a 1 or 2 line change, or build a feature that was just a single flag. But it took you, it took you a few hours or days to find it because you just simply couldn't find the code. It didn't make sense, and you were afraid to delete the code because you didn't know what it'd break. So take that feeling of frustration and tell me that architecture doesn't matter when it comes to developer performance. If we thought more carefully about how we build things, we would all be much more efficient at what we do. And it's funny that architecture is this foundation that we just never think about. Because for a computer, you know what a computer knows? It knows 2 things. It knows 0 and 1. The computer doesn't care about your job title. It doesn't care about your company. It doesn't care about how much money you make. It doesn't care about the framework you're using or the language you're using. The computer knows 0s and 1s. But it's actually humans that get in the way. It's humans that we have debates about structure and tabs versus spaces, or if Python's better than Java, is better than Nginx, is better than Apache, or should we use Amazon or AWS? We think about all these things, and even weird things like, 2. That's not a real number. But it's us that gets in our own way, because we don't stop and think about it's the architecture of our code. In fact, Right now, if you go into your Slack channel in your company, you say, hey, I think we should name all of our files in snake case. That's the way to go. Team snake case all the way. But there'll quickly be someone who says, like, no, team camel case. That's the way you name your files. And we'll spend days and weeks and hours arguing over this trivial things when all that matters in the end is this ones and zeros. So when we think about developer performance and architecture, all we need to do is just be consistent. It doesn't matter what your architecture is, as long as you're consistent. If you hired me today, could I go in and make a bug fix within an hour, a minute? You should. That's the way we should build things. And it's easy to say, okay, when you think about the performance of your architecture, just be consistent. But what's the trade-off that we're making to do that? We're trading developer freedom. I can't build the way that I want. I need to format all of my code to be 2 spaces instead of 4, or I need to change the way I indent my fonts, or things like that. That's what we're trading off, but that's okay. Because, yeah, engineering is about creativity, and being consistent limits that creativity just a little bit, but it helps for the greater good. Okay. So I went on a long rant about architecture and developer things. Let's build an app. I want to call it, oh my God, dogs. And of course, any good app in 2018, we need a mascot. So I think we'll use Pugsley here. The great thing about Pugs is that they always look concerned. Like, that's just their default look. For instance, Pugsley, he is over the moon that we're going to build an app about dogs. You can't tell? Yeah, he just looks really concerned. And we'll call this version 1. So we start off with the simple architecture, just some CSS, some HTML, a little bit of JavaScript. And now we get to the next part where everybody tends to have the best time. It's, what kind of libraries do we want to use? That's the first thing we always do. You're like, okay, I got a project name, I got a mascot. What should I use? So I think I'm going to use some React, because Jem said that was cool. I think I'll use Webpack, because someone tweeted that the other day, and they're pretty smart. I think I'll use Rollup, because, Webpack and Rollup, I don't know why, but yeah, sure. How about some Lodash? That's a good utility library. And, I'll throw in some Angular, too, because there's a lot of smart people that say Angular is the way to go. And we forget this core thing about performance in that for excluding network and transfer size, the slowest part of a web page, it's not the painting time, it's not the rendering time, it's the scripting time. It's the sheer amount of JavaScript, HTML, CSS that we send down to the client that is the slowest part of our application. But we don't think about that. We think about, what's the coolest new library that I can use? I heard someone talking about RxJS. I'm going to use that. So think about libraries. Think, does it make you more productive? Is this thing worth the page weight? Because developer productivity, again, it's the core of everything we do. But is it worth the page weight to the client? Are we saying it's okay to pay that cost that I can write code just a little bit shorter so the client can download just a bit more code and it builds up over time? Maybe. I'm not saying one's right, one's wrong. I'm saying this is the way we need to think about the problems that we solve in the future. But above all, choose what makes your team performant. The hardest thing I can say as an engineer is that you were right, I was wrong. How oftentimes do you say that? Not much. We'll get into arguments about which is better, which framework is better, but sometimes it just doesn't matter. What's going to make your team more performant? Okay, we spent a long time on developer performance because I feel so passionate about it. Let's talk about some code. Let's talk about the JavaScripts, the cool part of the presentation. And now we're on version 1.1 of our app. I built a button. It took me a couple hours, but I powered through it. And this button, when you click it, it gets you a dog. Oh, it's a dog and they're best friends. Oh, but there's a problem. So when I click the button and I time it, it takes well over a second for each image to load. That's not great. I think I can do better. I think we can build better. So let's talk about network performance. Let's talk about making fast fetch requests. Nobody's laughing at fetch. That's clearly a joke about fetch. No, nobody? Tough crowd in Switzerland. So if I wanted to fetch a bunch of items at the same time, what's the naive solution? What's the first thing you come up with? you'd probably use something like promise.all. Fetch a bunch of things, and then once it resolves, returns all the things. Yeah, that's good. I can fetch 10 images at once, but the problem with that, with promise.all, is that it waits until everything's done, and then it gives you back the first image. That's not good, because if we're loading 100 images, the user's going to click, and then they're going to wait, and they're going to wait, they're going to wait. And you're like, don't worry, the dogs are loading, they're coming. But we can build better than that. How about promise.race? How many people have heard of promise.race? Not many, and I will tell you why in a second. This is native JavaScript. Promise.race, what it does is, given a bunch of fetches, the first thing that comes back is the one that wins. That's awesome. So I can fetch 10 images, and the fastest image to come back is the one that's going to get returned to the user. So it guarantees that our fetch is going to be as fast as possible. But the problem with promise.race, and the reason why most people don't use it, is that it throws away all the other requests we made. So it still makes a request. It doesn't cancel them, but it just throws them away. They're gone. So that's not ideal. I care about my users' bandwidth. I want to build something that looks like promise.race, where the first thing that comes back is the first thing that wins, but I still keep the other images that I'm trying to fetch. What kind of data structure can I use to build that? What do you think? How about a queue? More importantly, how about a queue that automatically fills itself? So the minute someone gets an image, it just fills itself. It's a buffer. A buffer is just a queue that just keeps filling itself over and over and over again. So right now you're thinking, all right, a buffer, what sort of library we want to use? Because that, we learned nothing from the last lesson. So we want to use a library. And Jem, you work at Netflix, so I'll probably use RxJS, maybe. What about Bluebird? Yeah, those would work, but I think we can do Pugsley. See, now he looks concerned, because he remembers that earlier lesson we learned earlier about we don't want to load up too many things if we don't have to. I think that I can build a buffer in just native JavaScript. I think I can do it in a few lines of JavaScript too. What I want to use is a generator. A generator is just constantly listening for images, and it pops them off as I need them. And if you've never seen a generator before, you're probably thinking, something about this doesn't look right. Something about this code is, I don't know what it is, but it makes me a little nervous. It's a rookie mistake, and you're just like, get a little nervous. That's okay, because the great thing about a generator is that we can pause execution whenever we want. That's what the yield keyword does. So now we have a generator. The while true keeps it open. It keeps it always listening for new events and new images to come in. So now I've implemented a generator. I've implemented a buffer. Let's see if it made my app any faster. I don't know. Did it? Yeah, that's pretty good. That's substantially faster than what we had before. Yeah. Okay, so when it comes to network performance, we want to maximize all the connections. We want to saturate that. We want to get as much data as possible, as fast as possible. But what's the trade-off that we're making when we do that? We're using up the client's battery, we're using up their data. If I'm on a mobile device in, Johannesburg, do I want 100 images to load in the background if I can't see them? Is that fair? Maybe. Maybe. That's what engineering is about. It's about the trade-offs that we make. In case our app, I want them to get the dogs as quickly as possible. But we have these apps. We have the app, and it's fast, but there's a problem. See, I love dogs. You probably didn't know that, but a little fact. I love dogs, but they don't know how much I love them. I've only said I love you to one woman, and every dog I've ever met in my life. I love them. So let's build another version of our app. And this time, when we click the button, there's just the little hearts that come up from the bottom. It's just so dogs out there, they just all know and they feel that I love them and I care about them, and they're all good dogs. And that felt pretty good. That felt like it was smooth, but we're engineers. We don't just do things feel like it. We need to measure them. We need to measure the performance. So when we think about smoothness, does it feel smooth? Does it not jank? What do we measure that in? Well, we measure that in frames per second. So I implemented a frames per second counter, and when we click the button, We see like, oh, yeah, it's running at 60 frames per second. That's about what the human eye can determine. That's what makes it feel smooth. That's what human eye can determine change at. And that's pretty good. It's running at 60 frames a second. But there's a problem with measuring performance. This thing called uncertainty. It's the idea that you can't measure something without also changing it as well. For instance, in my very basic FPS counter, just calls request animation frame and it counts over and over and over again, and then every second we just say, what's the count? If that's 60, it's smooth. And then I report that. But the problem with that is JSON.stringify, that's a synchronous event. And I'm calling this every 16 milliseconds. I'm just JSON.stringify, JSON.stringify. So I guarantee if I implemented it like this, our frames per second would be maybe 30, maybe 15. And you'd be thinking, why is my app so slow? It feels smooth, but there's something wrong. It's because we didn't implement the way we measure things properly. Okay, so we absolutely need to measure what we do. We need to measure our performance. We should measure the frames per second. We should measure the time to render. We should measure the time to interactive. But remember, you have to always think about that uncertainty. Is the way I'm measuring actually changing the way the client is running? I've seen a lot of weird implementations of measurements, and I think a lot of people don't realize you can change the way the measurements look just by simply changing it. You can change the way the measurements look just by simply measuring. So we have to be careful when we do things like that. So now I want to talk about server performance. I know, you're all a bunch of UI engineers. You're thinking, what do I care about servers? Well, server performance is, to me, it's my favorite one. Because I can make a change, and despite all the thousands of devices that my code runs on, I can make a change that makes my app run so fast. In fact, by the time we get done with server performance today, my app will be twice as fast as it was before. And I don't have to change anything on the client. And that's pretty cool. But first, I want to start off with the exciting world of transfer protocol. Really exciting stuff. And transfer protocol, of course, refers to HTTP1. And my site running on HTTP1 is just simply, it's 2.1 seconds. That's kind of slow. I think we can do a little bit better. So I'm going to fire up my Nginx configuration, and I'm going to make one change. One change. I'm going to switch to HTTP2 and use this thing called multiplexing, where it just opens one socket and makes as many connections as possible. And now, I've got my site down to 900 milliseconds. Twice as fast, over twice as fast. And that was a one-line change. So as UI engineers, we always have to think, is there something on the server that I can make a little bit faster? We'll spend hours over our minifiers and our bundlers and our tree shakers, things like that, but we don't think, I can make a change on the server and instantaneously make my app that much faster. But what are you thinking? There's a trade-off to be made. I can't just implement HTTP2 to make my page faster. Why? Because I need to use SSL. SSL is expensive. It's not free. There's a computational cost to that. In fact, when Netflix.com moved to HBS, it cost us a non-trivial amount of money in server resources because we had to calculate all those hashes and the ciphers and all these things like that. But we generally don't think like that. We think, oh, HTTP2, my site's faster. But why is my AWS bill $100,000 a month? We didn't think about it. That's okay. For this app, it's okay. I can afford the cost. You know, I make a little bit of money. So I can afford a little bit of server costs. So now let's talk about compression. What are the two main players in compression? Broadly and gzip. Broadly's a little bit newer. I always think it's funny because it sounds like broccoli every single time. But most of us are familiar with some sort of compression. We make our files smaller over the wire, and then we just expand them on the client. And we should absolutely be using compression. In fact, using Broadly, I can get my file size 73% smaller than what it was before. gzip's pretty good too. Okay, so right now you're like, okay, I got one takeaway from you, Jem, and that's, I'm just going to use Broadly, it's the winner. No. There's a trade-off to be made. There's always a trade-off that we're making. Broadly is actually really slow. It's slow to compress files. gzip's much faster, but the compression's not as good. But I'm an engineer. I'm gonna beat this problem. how can we solve this problem? How about instead of we build our build step and it serves out to the web server and then we compress on the fly, how about we just mix up that order? We utilize this idea called static compression. We just compress all our files ahead of time and set them on the fly. So now we've taken that compression time to effectively back down to 0. That's pretty cool. So now we know we should use broadly to compress our static files. But again, what's the cost of doing that? It's the server overhead. It still costs CPU cycles and a non-trivial amount of CPU cycles to do this every single time. And it complicates our build step. But we do all this for the sake of performance. Because remember, I love 2 things, dogs and performance. And my fiance. And dogs and performance. So now we're in the final version of our app. Version 3, final. Let's check it out. Is it fast? Yeah, it's fast. It's smooth because we measured it. It's looking good. Lots of cute dogs. It's adorable. I love Rottweilers. But more importantly, we've learned to think differently about the performance aspects. We made a lot of trade-offs along the way, a lot of trade-offs to get that fast performance. And sometimes it's server performance. Sometimes it's developer performance. But remember, there's always a trade-off that we're making. So here we are. Back to that first question many years ago at Netflix. How do you have perfect engineering and perfect design? Well, the answer is you can't. It's a balance. You do one or the other, and you make a trade-off along the way. And as good engineers, we think about those trade-offs. And especially when it comes to performance, we have to make a choice about performance. We have to say, hey, I know all the costs that I'm paying. I'm putting all the costs on the client. I'm putting all the costs on the server, but we're doing it for the sake of performance. And that's okay, because at the end of the day, that's what makes a good engineer, understanding the trade-offs. That's what makes your application. Because we all make choices, but in the end, it's our choices that make us. Thank you.